So in this video, I'm going to talk about how to write a trend line using Desmos. So if your data is given as a graph, remember you want to use a table of values. So I already have a table of values in this problem, so I'm going to go ahead and use that to write my line of best fit. So we're going to start off by clicking the plus sign in the upper left-hand corner, add item, and then we're going to choose table. So it gives me a table as x1 and y1, and what I'm going to do is I'm going to enter these values into the table. So I enter my x values, 2, 4. You can see now Desmos is trying to predict the next value, but you can just ignore that and go ahead and type in the information from the original problem. So now my y values, so that gives me a scatter plot that it goes ahead and does as I enter the data points. So now what we're going to do is we're going to tell Desmos to approximate a line. So we're going to tell it y equals mx plus b, but we have to enter it as y1 because that's where the information is coming from. And then we say approximate mx1 because we wanted to use those x values from x1, and then we say plus b. So now what we do is it does go ahead and graph the line, and it does give us the information about the line. Under parameters, it tells us the values of m and b, so we have y equals 1.75x plus 3.5. It does tell us the r value. It says r is 1, which indicates that we have a perfect positive association in this data. So now using the equation, you can actually predict a value. So let's predict a future value. What is the value of this function when x equals 15? So what we can do is we can actually use this equation and we can plug in x equals 15 to figure out a future value. So we have 1.75 times 15 plus 3.5. So we can simplify this using our calculator. So in our calculator, we can type 1.75 times 15 and then plus 3.5. And if we hit enter, it tells us that value is y equals 29.75. So we can predict a future value using the equation that is given to us by Desmos. So now let's use Desmos to figure out if there's a relationship between the fat grams and total calories in fast food. So once again, I'm going to click the plus, add item, and then click table. And then I'm going to enter my fat grams into x1. So I'm going to go ahead and pause the recording while I just type in these values, and so you can do the same. So once you've typed in all your values, you just want to check really quickly and then just make sure that you've typed everything in correctly. So now we can see the scatter plot. If I zoom out, because these values are larger, I can see my scatter plot up here. Now I'm going to tell Desmos to approximate a line. So I say y1 is approximately mx1 plus b. And so what it does, it goes ahead and graphs that trend line. It tells me that the equation is 11.7x plus 193.9. So I can tell you that my equation is now y equals 11.7x plus 193.9. The R value is 0.97. So that is telling me that I have a strong positive association. Right? So there is a strong positive association between the total fat grams and the calories in fast food. So now this table shows us the number of hours spent studying for an exam and the final grade. What is the equation of best fit and predict the grade of a student who studied for 6 hours? So I'm going to just use Desmos for this one. You can choose your graphing calculator if you would prefer to do so. So into X1, I'm going to enter my study hours. So that's 2, 5, 1, 0, 4, 2, and 3. And then my grade is going to go into Y1. So I have 77, 92, 70, 63, 90, 75, and 84. Once again, I'm going to tell Desmos to approximate a line. So I'm going to say y1 approximately is mx1 plus b. So it does give me the equation of the trend line. So I can go ahead and write my equation now, which is y equals 6.1x plus 63.9. So now it wants us to find the grade of a student who studied for 6 hours. So we're just going to plug in 6 hours in for x because the hours was what we used as x. So we have 6.1 times 6 plus 63.9. So we can actually use our calculator to figure this out. So let's go ahead and let's do 6.1 times 6 plus 63.9. And if we hit enter, we get 100.5. So that means a student who studied for 6 hours is probably going to get 100 on the exam. So now we have a different example. It says a biologist is studying the relationship between a tree's diameter and its height. She records the data for the 7 different trees. So let's find a line of best fit to model this data. So what we're going to do, I'm going to do this one on the calculator just to show you a different way. You can use Desmos still if you would prefer to do so. So we type, remember we click stat and then edit. You're going to go up and then clear L1 and then go up and clear L2. And then in L1, I'm going to enter all the values of the diameter. So I have 2, 3, 4, 5, 6, 7, and then 8. In L2, I'm going to enter all the values of the height. So I have 8, 10, 16, 17, 22, 20, and 29. And so now we're going to use the line of best fit. So we're going to go to stat, arrow to calculate, choose option 4, click enter, and then choose calculate and hit enter. So it says y equals ax plus b, a is 3.178571429, b is 1.5357, and so we are going to approximate. I'm just going to round it to the tenths place, so we have y equals 3.2x plus 1.5. Okay, I'm going to use that as my line of best fit. Now it's asking us for the slope and the y-intercept. So remember in y equals mx plus b, remember that m is the slope and b is the y-intercept. So if I use that to figure out this line, I would say that the slope is 3.2 and the y-intercept is 1.5. Now it wants us to figure out the R value. So here it says the R value is 0.96. So that means that there is a strong positive association, right? Because it is a positive number and it is closer to 1, so it is a strong positive association. Now we want to predict the height of a tree that has a diameter of 5.5 inches. So remember, diameter is what I said was x. So I'm just going to plug that into this equation I just wrote. So I have 3.2 times 5.5 and then plus 1.5. Okay, so if I go and I plug that in, I'm going to go back to the home screen and I have 3.2 times 5.5 and then plus 1.5 and I hit enter. That means that the predicted height is 19.1 let's see, feet. So now it wants us to predict the diameter of a tree that is 25 feet tall. So it wants us to find diameter, it gives us height. Well, height, remember, is our value of y. So we have 25 equals 3.2 times x plus 1.5. So remember now we're going to have to solve this equation and get x by itself. So we're going to start off subtracting 1.5 from both sides because we need to get x by itself. So that gives us 25 minus 1.5, which is 23.5. So we have 23.5 equals 3.2x. Now what we're going to do is we're going to divide both sides by 3.2. So we're going to do 23.5 divided by 3.2. And that gives us, let's just round to the tenths place. So we have 7.3, and that would be inches. So 7.3 inches equals the diameter. So that's how you can use trend lines to not only figure out predicted values of x, you can also find predicted values of y. So if you want to find a linear function for data, remember that you can use 2 points to write the equation of a line. So we've been doing this by hand. You've been, writing equations of lines using 2 points, but calculating slope and then plugging into point slope or slope intercept form. You can actually use your calculator to help you out with this. So say we want to write the equation of this trend line, right? What we can do is we can pick 2 points. So if you zoom in a little, you can see I'm going to pick 2 points that have integer coordinates. Okay, so I'm going to pick this one right here, this 115. Okay, so 115 is going to be my first point. And then I'm going to pick another point with integer coordinates. Let's see, this one looks good, 935. Okay. So what I'm going to do now is just like when I had my table, I'm going to enter my X values into L1 and my Y values into L2. If you want, you can write this as a table. Sometimes people like to write it as a table just to help them get all the information sorted out. So what you can do is you can actually just go ahead and write it as a table. So let's see. Okay, so here I'm going to enter all my X values. So I have 1, and then I have 15, and then I have 9, and then I have 35, right? So what I'm going to do is I'm going to go to Stat and then Edit. L1, I'm going to start off by clearing it, right? So I'm going to go up, clear, enter, and then here I'm going to go up, clear, and then enter. In my left side, I'm going to enter my X values. So I have 1, and then I have 9. On the right side, I have 15, and then I have 35. And then I can do my stat, arrow to calculate, choose option 4, click enter until you get to calculate and hit enter again. And now it does give me the equation of the line. Okay, so the equation of the line that models this data is going to be y equals 2.5x plus 12.5. So that's how you can use linear regression to write equations of lines if you have data points that are plotted like this. So remember, given a set of data, you can write a line of best fit that models the data, and you can use this value to predict future data points.